Hi everybody, welcome to SMR Telugu Education. So next concept is dynamic memory allocation. Dynamic memory allocation. So in arrays we have to allocate a memory in static way. So int array of 100 means the memory is allocated for 100 elements. Integer size is 2 bytes, 200 bytes of memory is allocated. Here just we are using 5 elements, so 10 bytes of memory is used, remaining memory 190 bytes of memory is waste. By using dynamic memory allocation we can allocate a memory at runtime. So how much we want, that much of memory we have to allocate it. Which type we want, we have to allocate the memory by using the functions called malloc, calloc, realloc and free. By using these functions you have to allocate the memory. These functions are present in alloc.h header file. So by using these functions malloc, calloc, realloc functions, by using these functions we allocate the memory at runtime. By using free function we have to deallocate the memory. These functions are present in alloc.h header file. So malloc function, so this function, every function has return type, function name and then parameters. Similarly malloc function name is malloc. How much memory it is allocated, there is operator called size of int. Here the size of int is 2 bytes. Up to this statement the memory is allocated for 2 bytes. Some address, yes, some address is 500. So malloc function return type is void pointer. Void pointer is the return type. We have to convert this to which type of pointer. Here I am taking int asterisk ptr. Here the ptr is which type of pointer, integer pointer. We have to convert this to typecast this one to int asterisk. So by default malloc function return type is void asterisk. We have to convert that one to our wish, which type. Maybe it is a integer pointer or character pointer or array pointer or integer array pointer or employee type or employee array type. This is our wish. We have to typecast that one to this meaning. So up to this statement the memory is allocated for 2 bytes and then we have to convert this type, this pointer type to integer. Now we have to, here ptr is a variable. In this ptr, what is the address of this? Address of this statement is 500. This 500 is stored in ptr. Now this one is pointing to this address. Here the malloc function can allocate the memory of 2 bytes. This 2 bytes is by default, this one is void pointer. We have to convert this void pointer into integer pointer. Now this value is stored in ptr. Now now I want to allocate the memory for 5 integer types. Then one more thing, here by using malloc function the default value is garbage value. here the default value is garbage value. Now malloc size of, here the number of elements is, here I am taking 5 into size of int. Size of int. Here the number of elements is, here I am taking 5, then size of int is 2 bytes, 2 into 5, total 10 bytes of memory is allocated. One, 2, 3, 4, 5. So memory is allocated. First continuous memory, this one is some address 600, six hundred, 602, 604, 606, 608. Up to this the memory is allocated. Then this is a wide pointer. Now we have to convert this one to which type. Here I am taking int asterisk array, integer array. Now we have to assign this value to which ARR. So ARR is equal to, now we have to, ARR is which type of variable? Integer pointer. Now we have to convert this one typecast to int asterisk pointer. Here the memory is allocated for 5 elements. This one is first element, second, third, fourth, fifth. This address is, base address is 600. This 600 is stored in ARR. Here variable name is ARR. So variable name is ARR. This value is stored in 600. Now this one is pointing to this one. So here initial values is garbage values. This one is garbage value, garbage value, garbage value, garbage value, garbage value. So alt F new F2 alloc dot h, alt F new F2 alloc dot c. Dynamic dot c. So void main, int asterisk ptr, clrs here, clear the screen. Here malloc size of int, the size of int is 2 bytes. So 2 bytes of memory is allocated. Next, this is a wide pointer. Now here we are assigned to ptr. Now we have to typecast the which type? Int asterisk ptr. So this statement allocate the memory of 2 bytes. Allocate the memory of 2 bytes, and this base address 500 is stored in ptr. Now the ptr value is, ptr is pointer. How to access? Value asterisk ptr. So percentage d comma asterisk ptr is the garbage value. Maybe it is a sometimes 0. We don't know. Alt F9. Yes. Control F9. Alt F5. So garbage value is 0. Now how to access variable at that location? ptr is address asterisk ptr is value, asterisk ptr is equal to 100. Now here initial value is 500. Now this value is replaced with 100. So ptr is 500, asterisk ptr is 100. Now asterisk ptr is 100. Now the output is 100. So run this code, alt F9, yes, control F9, alt F5, output is 100. If this function malloc function allocates the memory of 2 bytes, sometimes memory is not available, then this function returns a null value. That means that if ptr value is equal to null, means memory is deallocated. So printf memory is not available. So exit of 1, exit this code. So exit function available in process.h header file. So what is null? If you want to run this code, we will get an error, undefined symbol null. Alt F9, we will get an error, undefined symbol null. So null is available in which header file? alloc.h header file. You have to include that one, hash include alloc.h header file. Okay. So null, if this function fails to allocate the memory, then this function returns null value, then ptr value is equal to null. If ptr is equal to null means memory is not available, and exit the code. Otherwise you have to run this code, alt F9, yes, control F9, alt F5. So output is 100. So in this statement, so size of number of elements 5 into size of int. Here the memory is allocated for 5 continuous elements. This one is error of 0, error of 1, error of 2. This one is error of 0, error of 1, error of 2, error of 3, error of 4. So 0, 1, 2, 3, 4. This one is error of 0, error of 1, error of 2, error of 3, error of 4. So initial values is garbage value. This one is garbage value. So alt F, yes, alt F A. Array dot C. Here I am taking the number of elements. It is here I am assigning number of elements is equal to 5. Otherwise better to scan the values. So int number of elements. So printf enter number of elements. Scan that value, scanf %d comma address of any. So we are entering 5. The memory is allocated for integer size is 2 bytes. So 5 into 2, 10 bytes of memory is allocated. Here I am taking array name is ARR. So ARR is which type of integer pointer. That's why you have to typecast this one to integer pointer. If ARR is this function fails, then returns null value. That means ARR value is equal to null, then memory is not available or exit. Now first element is for loop purpose. Here I am taking I value. Initial value AR of 0 is garbage value, garbage value, garbage value, garbage value. I want to print that values for I is equal to 0, I less than number of elements I plus plus. Here I am printing printf percentage d some space comma error of I. That means starting element is error of 0, error of 1, error of 2, error of 3, error of 4. Alt F9, yes, Control F9. Garbage values. Here number of elements 5, Alt F5. So 35, 10, 4, 4, 7, 8, 5 garbage value 10, 9 to 1, 6. These are by default these are garbage values. Okay. So instead of garbage values here I am entering for I is equal to 0, I less than number of elements I plus plus. Here ask the user to enter the value. So enter percentage d element comma I plus 1. First time enter first element, second element, third element. So scanf percentage d comma ARR plus I. So by using pointers, ARR means base address, plus 1 means next address, plus 1 means next address, plus 1 means next address. Okay, at the time of printing, instead of writing this statement is equal to ARR plus 1 plus I means address, asterisk means value at that location. This is the pointers concept. So pointers concept is very important. So Alt F9, yes, Control F9, enter number of elements 5, first element 10, second element 20, 30, 40, 50. Alt F5, 10, 20, 30, 40, 50. Next one is, if malloc function fails, then this function returns null value. One more thing, the ASCII value of null value is 0. The ASCII value of null value is 0. So directly I am writing 0. Both are same. Alt F9, yes, Control F9. Number of elements 5. 1, 2, 3, 4, 5. Alt F5, 1, 2, 3, 4, 5. Next one is calloc. Calloc. Here the calloc function parameters. Every function has return type, wide asterisk, function name, calloc. Number of parameters is 2 parameters. Here the number of elements, comma, size. Size of which type? Size of int. Here the calloc function return parameters is 2 parameters. Here I am assigning to integer type, then we have to typecast to int asterisk. This should be assigned to ARR. So this one and this one both are same. The only difference is calloc function, the default value is garbage values. Here the number of elements is 5. Then the memory is allocated for 5 elements. The memory is allocated for 5 elements. So first element, second, third, fourth. Same array name is ARR. Here the only difference is starting value is 700, next address is 702, 704, 706, 708. Here the initial value is 0, 0, 0, 0, 0, 0. The first element is error of 0, error of 1, error of 2, error of 3, error of 4. So first, second, third. So initial values is garbage values. So please remember CLOC function, the number of parameters is 2 parameters. Enter number of elements. Here the function name is CLOC. Here the number of parameters is 2 parameters. If you run this code, we will get an error. Here the CLOC function 2 parameters. Here we are giving only 1 parameter. Alt F9, 1 error. So too few parameters in call to CLOC. So CLOC function has 2 parameters, number of elements, first one, next number of size of int. So CLOC function, this function returns null value when this memory is not allocated. If this function is not allocated the memory, then this function returns null value. Here the memory is allocated for continuous memory allocation. Initial values is, and comment this code. The initial values is zeros. So Alt F9, yes, Control F9. Number of elements 5. Alt F5, 0, 0, 0, 0. 5 zeros. That is the difference between malloc and CLOC. So here, so I am assigning value 10, 20, Alt F9, yes. Number of elements 5. First element 10, 20, 30, 40, 50. So Alt F5, 10, 20, 30, 40, 50. Here this value is replaced with 10. This one is 20. This one is 30, 40, 50, and so on. This is malloc and CLOC. Now in our code, first memory is allocated for 5 elements. Then I want to change the size of 10. Then you have to use realloc function. Realloc. I want to resize the ARR. Here the ARR size is here ARR size is 5 elements. I want to resize this 5 elements. I want to increase this size. Reallocate. So realloc function, I want to reallocate ARR. Now mention the new size. New size is 20. Here the size is 5 elements, size is 10 bytes. In this code, I want to run this code. Elements is 10, 20, 30, 40, 50. Now this ARR value, this value is 10, this value is 20, this value is 30, this value is 40, this value is 50. This one is 10. 10, this one is 20, 30, 40 and then 50. The reallocate function, the memory size is 20 bytes. Here the memory is allocated for 10 elements. Here the memory is allocated for 10 elements. So first, second, third, fourth and then fifth, sixth, 7, 8, 9, 10. So realloc ARR of 20, this function copies ARR value. ARR value is 10, 20, 30, 40, 50 is copied into this location. So 10, 20, 30, 40, 50, 50. So remaining values are, remaining memory is available. Now this one is which type? We have to allocate this one to ARR. ARR is which type? Int asterisk. I want to typecast this one into int asterisk of ARR is equal to int asterisk of realloc ARR comma 20. If this function fails, then returns the null value. Same. So after writing this code, I want to realloc, I want to call realloc ARR comma size is 20 bytes is allocated to once again ARR int asterisk of, now this size is 10 elements. So I want to write for loop for I is equal to 0, I less than 10, I plus plus. I want to print that values, printf percentage d comma asterisk ARR plus I plus I. The starting value is 10, next value is 20, 30, 40, 50, remaining values is, remaining memory is allocated, remaining values is zeros, 0, 0, 0, 0. Alt F9, yes, control F9, number of elements 5, first element 10, 20, 30, 40, 50, Alt F5, so 10, 20, 30, 40, 50, remaining elements are null values. So here I am giving some space. So first comment this code, first elements. Okay, this is the first 5 array elements. Next you have to reallocate that one. Here I am giving some message, printf after reallocation. After reallocation of memory, then slash n. So Alt F9, yes, control F9, number of elements 5, first element 10, 20, 30, 40, 50, Alt F5, 10, 20, 30, 40, remaining elements are 0, 0, 0, 0. So these are the malloc, calloc, realloc. By using free function, we have to deallocate that memory. So please remember, if malloc, calloc, realloc function fails, then they returns null value. So note, so malloc, calloc, realloc functions fails to allocate a memory, then returns null value. So if these functions returns a null value. So by using free function, we want to deallocate the memory. So I want to deallocate this memory of ARR. At the end, you have to use free of ARR. Now this memory is deallocated. Now this memory is not available up to this statement. So this dynamically memory allocation is available in, so throughout the program anywhere you can use this memory of malloc, calloc, realloc functions. What F9? Yes, control F9. So number of elements 5, 10, 20, 30, 40, 50, alt F5. Here int asterisk ptr clr scr. So clear the screen. Now ptr is equal to int asterisk malloc size of int. So this function allocate the memory of 2 bytes. Then we have to typecast that one into integer pointer. Now asterisk ptr is equal to 10. Now print that one, printf percentage d comma asterisk ptr. Now pre of ptr so please remember this function malloc size of int. So this function allocate 2 bytes of memory, some address 500, then initial value is garbage value. This one I want, we are allocating this value to int asterisk some ptr value of type int asterisk ptr. Now I am allocating this value to ptr. So ptr is which type? Int asterisk type. That's why we are typecast that one to int asterisk. So malloc size of int. So please remember up to this statement, this statement, this memory is allocated. Now we have to typecast this one into, we are typecasting to int asterisk ptr. Now ptr this statement ptr is equal to int asterisk malloc. This meaning this value is 500 is stored in ptr. That means here the ptr value is 500. Now asterisk ptr is equal to 10. That means this garbage value is replaced with 10. Now I am printing printf percentage d comma asterisk ptr. Now this prints 10 value. Now I am we are using free function. free of ptr. So please remember, free of ptr function deallocates the, what is the ptr? 500 address. This one is, this function, this memory is deallocates, this memory is deallocate. So now this one is nowhere in memory. Now tell what is ptr. Now what is ptr? So what is ptr? Ptr is 500. So what is asterisk ptr? Asterisk ptr is not available in memory. Not available in memory. Okay, that is the difference. Free of ptr function deallocates the this memory, but this 500 is available in ptr. I want to null this one. How to write? ptr is equal to null. Now this value is 0. Null ASCII value is 0. Now printf %d /n %d comma asterisk ptr. So now this ptr is not available in memory. Asterisk ptr means some garbage values. Alt F9, Control F9, Alt F5. We don't know the value. After free this function, now ptr is equal to, you have to assign null value. Now this asterisk ptr is Alt F9, Control F9, Alt F5, 0. So please remember, free of ptr function deallocate the allocated memory. After deallocating, we have to assign ptr value to null. Otherwise, sometimes maybe you have to come the same value. If you don't write this line, maybe that memory is not available, but it is sometimes it come 10. This is the mloc, cloc, realloc and free functions. So still you have any doubts, please refer once again. Thank you for watching.